Okay. So now we're going to start with the new topic today. It's basically called work, power, energy. Work's definition is that work is said to be done when an object moves a displacement in the direction of force applied. Work is given by force times displacement. Please do not forget about that. In this one, this is your force. That's bad. Wait a second, please. It dies down. Okay. And S is the displacement, and that would be the work done. Remember that work done is a scalar quantity, and the SI units for work done are joules, like that. For instance, in the case 1, you apply a force and then you move a displacement S. So work can be found out by simply multiplying this displacement with the force because they are in the same direction. Is it clear, kids? Okay. Now, in the next case, think about it. The satellite here is being pulled by Earth with a force F. That's the gravitational force. But the satellite is moving like this. So that is the displacement. Do you guys think there is work happening on it by the gravity? If you think there would be work, what would be the value for that or the formula that you're going to use? Yes, kids. Do you guys think work is happening due to gravity on the satellite here? Okay. And how do you find that, Asma? You just multiply it with work equals to force times displacement. That's it. What do you say? Okay. All right. Give me a definite answer, please. Yes, Abdullah, what do you think? Alameen, Tejasvi, Fatma, Fiza, Shazeb, quickly, please. Do you think the gravity is doing work on the satellite or not? Zoya, Hajra? What is the condition for work to happen, kids? It is said to be done when an object moves the displacement in the direction of the force. Is the force and the direction of displacement the same? Yes, Hajra, excellent answer. That is correct. Work done in this one is 0. And the reason is because the object does not travel a displacement parallel to the force. Is it clear, Asma? Very good. Always remember that. Do not forget this point. Your displacement must be, this displacement must be parallel to the force. Now check this one out then. In this part, if I ask you, what is the work done on this object that is rolling down? What would you say? Okay. What would be the value of it? Can you give me a formula for that in terms of these variables, please? W times S. Okay. Is that correct, Tejasvi? Do you think W and S are in the same direction? Okay. Fiza thinks W times H. All right. What do you think, Abdullah? W times H. That is 100% correct. So this is your method one, where we're looking at W times H is the work because this force and this distance or displacement is in the same direction or parallel to each other. All right. Is it clear, Hajra? Everything is clear now? Should I go forward, please? Now let's check out method two, please. So in method two, we can make the components of it. So one is going to be down the slope, as you've learned it before. And then you can make one, oh my God, that's not fair. And the one like this. So this will be theta. This will be W cosine theta. This will be W sine theta. Now, the other thing is the force, if you find the component of it, which is W sine theta, along the surface of the slope, then work done, you can multiply with S as well. This will be work done as well. Is that clear, kids? Now, the question is, how is that even possible? Like, why is W sine theta times S is the same work done that we find through this? It's pretty simple. Think about it. If this is a triangle, so sine theta is opposite over the hypotenuse. The opposite in this one is H, hypotenuse is S. If I substitute it right here, what you get is W. Instead of sine theta, I'm writing H over S. There is S already there equals to work. So if you cancel this out, you will end up with the same answer as this one. Do you guys understand? That's why both methods are 100% correct. Is that clear, kids? Any questions now? Please let me know. Yes, why not? You see, when you have a slope situation like this, you got to make two components. One component is going to be down the slope always, and one component is going to be perpendicular to the slope. Okay, Hajra, like that. Always remember that this theta is always the theta between the perpendicular and the weight, which means this will become W cosine theta and this will be W sine theta. Do you understand that? As you can see, this force right here is parallel to this displacement. So I'm saying that actually work done can also be found out if you use W sine theta times the parallel displacement. Up till this point, are you clear? Okay. Now think about it. This is a triangle, as you can see, and you know that sine theta is given by opposite over the hypotenuse. The opposite in this is h, the hypotenuse is s. You agree? Can I replace this sine theta and this sine theta right here with s over h then? Because that is equal to that. Okay. If I do that, then kids, check it out. There's w times, instead of sine theta, I'm writing h over s. There's already one s right here, which is being multiplied, and it is equal to work done. So s and s is going to cancel out. What are you left with? W times h, and that is the same thing as method 1. Get it? Yes, very good. So both methods are required in your exam. Sometimes they will not give you the height. So you need to learn both of them. They're very important. And you shall see when we are going to do the questions ahead. All right, kids. So I think that is enough for today. I hope this session helped you in some way or